Hello, everyone. Those who are joining us, hello, hello. Those who are joining us, hello, hello. Hello, everyone.
Hi and welcome. We are preparing for this webinar. Welcome. Have your tools ready to experiment with.
Hello, all those who are joining. Welcome, welcome. We will soon start the webinar. Welcome, welcome, welcome. Welcome, welcome, all those who are joining us. We'll start in a minute. Welcome everyone to this webinar series of Lab4U. Thank you so much for joining us again in a Lab4U webinar. This time we will be working with a tool that many of you like and many of you have asked us to work with, which is the Sonometer. I'm here today with our great teacher, Javier, the head of the department at Lab4U. Thank you so much, Javier, for always joining us in this craziness with webinars. Javier here with everyone in the chat as well. I see in the chat many known names and familiar faces and names. Some of our Lab4U teachers, Brodney, Miss Martha, hello again. Thank you so much for joining us. Those who are joining us today, don't forget to download Lab4Physics. If you already have an account, you just have to log in. If you don't have an account, you can create a new account and our team will be helping you in the chat, either here on Zoom or on YouTube. We are on YouTube and on Zoom. And today, because we're going to run an experiment with Mr. Javier, we will need some materials. So have handy a ruler or a measuring tape. And we really hope that you're listening to this webinar from a different device that your smartphone, because you're going to use your smartphone or tablet as a measuring instrument. So we want to make sure that you are listening to this webinar from a device that is different from your smartphone where you have Lab4Physics, because we're going to use your phone or your tablet to experiment. So thank you again for joining. Those who are joining right now, thank you so much. I see more names coming in. So that's fantastic. We're here with Javier and extended Lab4U team who's going to be supporting us, Alyosha, Claudio, etc. So we and Maria Jose. So we're going to be here in the chat supporting you all. Objectives here today, we want to experiment. I mean, you don't want to listen to me. You want to listen to yourself while you are experimenting, and you want to listen to our teacher, Javier, our educator in-house, Javier, who's going to show us how to use Lab4Physics tool Sonometer today. And we're going to analyze the pertinence and the importance of experimenting during these pressing times. I hope all of you are staying well and healthy with your families, with your students. We know that these are very difficult times, so very important to know if you're well. Write in the chat where you're logging in from and how are you today. We know that in California also there have been some fires and some smoke, so I hope you and your families are doing well. Quickly, the agenda today, we already went through the introduction. Mr. Javier is going to talk to us about the Sonometer, and we're going to demo it and we're going to experiment today. And at the end, we are going to speak about inquiry, the pedagogical structure of the experiments and the importance of inquiry. And I'm sure that all those who are joining in today know the importance of experimentation, and I guess that's why you're here today with us. But for us at Lab4U, in our mission to democratize science and change the way science is taught, we know the importance of STEM education, of STEM knowledge, and preparing students for the future of the workforce with 21st century skills in this rapidly changing future. And the best way to do it is through inquiry and experimentation. We know that many have been affected due to this pandemic, and we're learning from home, we're experimenting from home. So at Lab4U, to democratize science and change the way science is taught, we are transforming smartphone sensors into complete science labs. And just briefly, you were able to see a brief demo of Lab4Physics, but as you can see here, students in a classroom, they're experimenting, pendulum movements, centripetal acceleration. Here they're analyzing distance and displacement, and they're graphing it. Here they're analyzing force, mass, and acceleration. You can experiment. Soon we will have some webinars with Lab4Chemistry where you can calculate concentration based on color. Just like you can see here in the video, students take a picture with our algorithm that uses computer vision, and they calculate the concentration of a solution. And many of you might be asking, Kamal, we are seeing here that students are in a classroom, they're experimenting. What about experimentation during COVID? We are seeing it with our teachers around the world. These are some pictures from Mexico. Students are experimenting at home. Incredibly, and they're sharing it with their teachers on social media. They're building WhatsApp groups, Facebook groups. They're experimenting, taking pictures and sending it to their teachers. So if it is possible for students around the world, like in Mexico or in California or in Florida or in Texas, to experiment at home, why not all of you today here in this webinar? For us at Lab4U, technology is just a means to an end. We need to think about the pedagogy and the educational experience, and that's why we are here today. So don't forget to download Lab4Physics. We're going to work with Lab4Physics today. As you know, Lab4Physics has experiment section and a tool section. In the tools today, we're going to work with the Sonometer. You can check out all the experiments. Many of you have worked with the experiments. Don't forget that you can download the experiments in case you don't have Wi-Fi all the time. You can download the experiments and work with them offline, and we're happy to help you validate that feature. And without further ado, I want to invite Professor Javier, our teacher in house. Javier, to work with us with the Sonometer. Is everyone ready for the Sonometer? Just type in the chat if you're ready to experiment with the Sonometer. Don't forget to download Lab4Physics. We're going to work with the Sonometer today. Javier, I'm going to leave you the digital floor here so that you can help us learn more about the Sonometer. And I'm ready with my phone here. Fantastic.
Okay, so welcome everybody. We are we will be seeing today a tool, a very useful tool to analyze and to compare different sounds. So the idea is that I don't have to explain you how does it work. We can just try it. Just do the thing that it does. In order to do this, you need to go to the homepage of Lab4Physics and open this sonometer tool that it has a purple icon. So once you open the sonometer, you will enter in this home screen when you can select new measurement or save results. Since probably this is the first time that you use the tool, there won't be anything on the save results. So the interesting part is on the new measurement. Once you press that, you will see a clean screen with a timer on the top, with a very small indicator that's pointing out 0 hertz right now, and an empty plot here in the middle of the screen, and a go button ready for you to start. So we will play this game, play everywhere in the world, called Simon Says. And the idea is that we will be humming to our phone. We can hum a tune, we can hum a rhythm, we can hum whatever we want. But it's very important that you press the go button before we start humming, and you press it the stop button that will be showing on the screen afterwards, so we can do a proper measurement. Okay, so Simon Says, are you ready? Set
Yes.
ready on the chat. So we have Brodney ready, Michael ready, Russian ready, cool. Miss Tyler ready, Anastasia ready, cool. So we can go on. Simon Says, press the go button. Simon Says, hum a tune. And Simon Says, stop. Okay, what do you see? Let's figure this out. You can activate your camera and you can show us your results, as Michael and Martha and Kamal is doing right now. We can see Michael has a very intense humming. We can see Anastasia with a very interesting graph. Okay, can you identify when you hum and when you were quiet in the graph, more or less? So the first thing that you will see is a intensity versus time plot, and in that you can maybe address when you were making a sound or where on or where the microphone picked up me talking through the speakers, right? And the second plot is a frequency versus time plot, and there you can check how uh, accurate you were on your humming. If you were humming on a more acute note or more bass note, then you can check how the graph moves and how was the tune. If you can't identify any of those things, maybe you need to try again and do another try. In those plots, you could see that the intensity versus time plot is very smooth, is very regular, or maybe more predictable than the frequency versus time graph. And in that graph, you should be able to see a period of time where the intensity of the sound was more or less constant, and that's where you more or less were humming.
And Mr. Javier, just for the audience here who's watching us, can you explain us the difference between the intensity versus time graph and the frequency versus time graph?
The intensity versus time describe how loud the sound was, and in terms of a physical quantity, it measures more or less the energy that the sound was carrying through the air. Uh, and the frequency versus time is a characteristic of the wave that was transmitted by the air. But those quantities are independent. You can have a loud and a low frequency and a very quiet and a high frequency sound. So when you analyze the frequency versus time plot, you usually see a more disorganized plot because it's picking up the sound from everywhere. So in the microphone, it may be picking up the sound outside your room, the sound from the speakers, the sound of your voice, everything mixed up. So the sum of all the sounds can be a wave that's very high in frequency or very low in frequency. But you need to identify when you were singing those periods of times also that the frequency was stable. Stable meaning that several dots are more or less the same. We will be doing an experiment with a pure sound, so you can see how stable is that measurement. But the idea here is that you recognize that this plot is harder to analyze than the intensity plot, because the intensity plot is very direct, is how loud, but the characteristic of the sound, the frequency, can be a mixture of different sounds and different sources. If you are in a room, it may be the same sound bounce over from the walls and coming back to you, that mixed up with the sound that you're emitting at that point. So it may be a uh, complex plot, but the characteristics that you want to address are the periods of time where the quantity was more or less stable. If this experiment was interesting to you, it may also be interesting for your students. And your students can do a very, very short but very cute experiment called Merry Gurizo Wavy. That's on your Play Physics category on the experiments tab. And that experiments ask you to do more or less the same, to whistle or to hum a tune, and to see what does it mean in terms of the quantities that you are measuring on the sound. And if you want to save this experiment to maybe analyze it further, or maybe send it to your computer to further analyze it, you can save it pressing the save button, give it a name, and it will be saved on the tab, on the button on the home screen of the tool that we showed earlier. This tool can be useful to talk about a lot of subjects directly, to talk about frequency as a characteristic of the sound that's very hard to identify, to pinpoint. Some wave phenomena like interference, reflection, attenuation. Attenuation we'll be talking later on. We will discuss this in our experiment today. And this opens the door to talk about health, in particular about noise pollution and the stress derived from living in a city that may or may not be harmful in the long run. In the short run, you may hear some acute stress, like after a concert, a live concert, but that kind of very high exposure to noise can also be done over time with no so loud sounds. So it's very interesting to understand that this may be affecting, especially our students with the headphones, and so this is very interesting to understand, to discuss with them, and maybe you do a science project with them on their school. How loud is the school? That's an interesting question, and a scientific question that can be addressed. So, everything ready? Everyone understand more or less what the sonometer does? If you have any question, please ask in the chat. We will be addressing them. Maybe if anyone else has a question. Yes. So we will be very, very aware of the chat in the meanwhile. But let's prepare for our experiment if everything's okay.
Yes, my favorite part. Let's experiment.
We have an there. So for this experiment, we will need you to figure out your space around you, because we will be moving, okay? So the
Okay.
idea is that we will emit from my computer, we will emit a sound, a constant sound in intensity and in frequency. And that sound will be reproduced on your speakers for 30 seconds. In the meanwhile, you will be using the sonometer to measure that sound, but not at a constant distance from the source. You will be moving away the cell phone at a constant velocity, at a straight line, obviously, away from the speaker, and we will see what kind of plot does that result. We will using the sonometer to just do that. So figure out your space, figure out where you will be moving the cell phone around, and try to mimic the movement that you will be doing later on when we're playing the sound. Okay? So place your ruler, your measuring tape, and figure
Okay.
out the kind of movement. Maybe you need to stand up, maybe you
Oh
don't.
wow, Miss Martha has a really big ruler there. I love it. Oh, look at
Yeah,
that.
it's a very
I
pro
love it.
ruler.
I have a small one here.
Everything it's okay. You can do it along a wall. Maybe you can do
Okay.
it perpendicular to a certain
Or a
surface.
measuring tape if you have a measuring tape as well. So
Yes.
Mr. Javier, so we are going to move our phone from the computer. So I have you on my computer right now, and I'm going to move you with move my phone with constant velocity from the computer, correct?
Away from the computer, yes.
Away from the computer, and you are going to emit a constant sound.
Constant sound.
Yeah,
We will,
sometimes that sound might be annoying for some. So if you're using headphones, make sure that you remove those headphones and you listen to it from your computer without the headphones. When Mr. Javier did it last time, I had my headphones on and it was not agreeable at all. So my
it's not a
recommendation
very
is
good way to measure sound to use headphones. You need to use the speakers of the
yes.
computer. And if you have any trouble and maybe feel annoyed by the sound, you can mute the sound for a few seconds. We will be showing an animation of a clock, so you know when the sound is off and you can listen to us again.
Awesome. Let's do it.
The idea is that before we do it, and it's very important this step, before we do it, you already have a certain feel of what you will get in the plot, in the graph that we are measuring, how the sound will be as you move away from the source. So the question that we are asking you right now is, what will be the shape of the graph? And in order to answer that question, please write down your answer on a piece of paper. And if you are bold, do a sketch of the graph that you think we will be getting and share the answer with the chat. Let's discuss this before we experiment. What would the shape of the graph be?
Great. So, what will the shape of the graph be? Write down your answers and sketch the graph. You can do it in a notebook, on a paper, on your computer. Write it down, sketch the graph, and share it in the chat. What is your prediction here?
If you want to show us the graph, you can activate your camera and show the audience what you think the graph will be.
Yep. So,
A
what
very
is
unusual question that is not always present in all the curricula of all the countries, but it's a very interesting question.
so? Ana Maria Lisotti is saying an hyperbole because it's lowering fast.
That's an interesting idea.
Interesting, yeah. So how will the graph be? So with the in with
Michael
the
says like a sine, something like that. As distance increases, it will drop the frequency will drop and the intensity will not change much. That's a bold assertion. That's a very unusual answer, but we will see. We will see.
yeah,
How
Miss
that?
Martha saying
What did
she's
you say?
predicting.
How that says is a like a wave that it's lowering its amplitude. I think. Am I okay? How that if yeah.
So Miss Martha is saying the prediction increasing plateau and then decreasing. If the tone emitted is consistent intensity, my phone will start away from computer speaker, then close to it, then away in the opposite direction. Okay, so increasing plateau and then decreasing. Okay, that's what Miss Martha says.
So there's a very wide range of opinions right now.
I
That's
love these predictions.
yeah.
I want to read more predictions.
This is not a typical question in a physics classroom. Usually, it's how fast an object will drop. This is very different, right?
Indeed, indeed. One more prediction. Come on, one more prediction. Will
Yeah.
you?
I will produce it in
Yes.
a couple of seconds. There is an important part in this process, in every inquiry process, and it's that the the prediction, the previous idea has to be put on paper before we do the experiment because our memory is very frail. So we will think that we have the right answer even though we didn't think that because our memory will betray us. So we will try to put it on paper to remember how what we answer, and then we will pair the answer with the actual result of the experiment.
Awesome. Mr. Javier, Mr. Brodney is asking, will the intensity change
If
when you
that's
emit?
your idea, it's it's a perfectly good idea to say that it varies, but it's better to say how it will vary. Yeah,
Okay, and
it
then
will increase, and if it increases, how? Exponentially, linearly, quadratically, logarithmically. Those are very different kind of behaviors.
and
And
Roshan
same
is
with the
saying,
frequency that Roshar is addressing. If the
right,
frequency varies with distance, the question is how? How it will vary. Okay,
right.
so if everyone is ready,
Yes, I'm ready.
so place the ruler, wait for the countdown to press go,
Okay.
and be aware that if you're not satisfied with the measurement, we will be repeating the sound after a couple of minutes. Okay,
Yeah.
so
There's one last prediction. Huda says the amplitude changes exponentially, but the frequency is the same.
exponentially increasing or decreasing?
Good question.
Yeah, because it could be a positive exponential or a negative exponential, and those are very different.
Yes, indeed.
So I will be playing the sound, so be ready. Put your cell phone near the speaker. So
Yep.
3, 2, 1. Okay, okay. How it went?
I just don't like the sound of it.
I will restart the clock in case we have any issue. Let's see. What did we get from our graph? What can we
Here,
say from our graph?
I'm showing my graph.
Kamal is showing. It's not really clear, Kamal. If you can move your cell phone up a little bit.
There. Ah, there.
Stan
There, there.
is also showing his graph. It's very weird.
There, Miss Martha's also showing.
It's
Which
showing
one
like
should we show?
a drop
Intensity or
and then
frequency?
an up.
Which one should we
Michael
show?
is constant, really constant. Brodney also really constant.
Oh, wow.
What happened there? Anastasia is also, but not that constant. It has some undulations. Are we seeing the intensity versus time plot, or are we seeing the frequency versus time
Which one
plot?
should we show you? Intensity or frequency?
The intensity is the more interesting one. The frequency should be also noticeable, but we can check if our measurement was more or less okay, if our cell phone is working properly, uh, seeing what's the frequency that we get more or less. So look at the frequency versus time plot. Identify the characteristic frequency and put it on the chat. We
So
will compare.
what's the frequency? Mr.
What's the
Javier is
frequency that
asking,
you
what's
get?
the frequency?
It should be a more or less constant quantity, more or less.
If it was constant, how much did it give you? Oh, there, Brodney's saying 523. Roshan is saying 524 hertz. What's the frequency? Michael says 523 hertz. And Miss Martha is saying frequency varied from 522 and 524. I love how she's always very precise and
the
exact.
the frequency emitted was more or less, because there's always a roundup in computers, 523.25, so 523 and a quarter. And that means that you measure more or less the frequency of the a C note.
A C note.
Yes, a
C
C,
major, C sharp, or just C?
just a C, a full C, and it's a 5 in a piano. If you see the keyboard, the fifth C that you see on the piano,
Middle C.
middle C. Thank you.
And
And that's a very interesting note, because it's not an integer, it's not a full number. As I think that there's a very precise note that we use as a full number, but the range of the results that we get shows that we are looking more or less at the same results. So what happened with the intensity? Very different expectation from different persons. They were saying that as we move away from the speaker, we will see a decreasing in different ways, and we didn't see that in any case. What happened? What do you think it happened? I will move on to the next slide, because I think we all get more or less good results, unless there is some problem and you want me to repeat the experiment, and that way you can have two data points,
do you
two,
want
two
do we
different.
want do we want Mr. Javier to repeat the sound? Do you want to try it again? Just chat, write in the chat. Do we want him to
Yeah.
repeat the sound? We want to try again?
Yes,
Yes, ma'am.
that's required.
Yes. Let's do it. Once more, once more. We're going to repeat the sound.
Okay.
Oh, God. There we go again.
Yeah, with the piano also works, but you have to do with two people, because one should play and the other one should move the cell phone.
Mrs. Martha,
Okay.
do you have a piano? You want to do it with a piano? She says it's
Okay.
over there.
We will emit the sound. Be
Okay,
ready.
wait. No,
If you
there we go.
to hear the sound, if you're okay with your results so far, please wait us 30 seconds, mute us when you see the clock running, and unmute us when you see the clock stopping. Okay? So,
Okay.
3, 2, 1. Okay, are we on? Yes, I think we are on.
Yes.
We can now move on through to the last questions to analyze our results. Did we get the same? If you repeat the result, did you get the same? What changed? What happened? If you did get the same, what are you seeing right now? Does the results match the prediction that you made earlier, or are they completely different? Please share the comments on the chat. We'll be reading them.
So Roshan says I got 265 hertz this time.
That's interesting.
Yeah, it is.
Because
Range
it's
in
more
sound
or less half
intensity.
of the sound.
And Michael says range in sound intensity expanded as the distance from the speaker increased. Range in sound intensity expanded as the distance from the speaker
Increase.
increased.
What do you mean by expand? Oh, like the dispersion.
A Doppler effect, Huda says.
Yeah,
Brodney says, I had the same frequency.
cool.
Frequency range. Perfect.
Doppler effect. Oh, maybe Doppler effect. I don't think so. Doppler effect should be dependent on the speed, and if the speed is slow, then the difference should be really small with the same really same frequency. With in the case of Michael, I think Michael is not hearing only the sound from the speaker. He's also hearing the sound coming from the wall that's just behind you. So it may be bouncing, and that bounces may distort the sound. And in different points of the room, you should hear different things. In the case of Russian, it's very interesting because it's almost half of the frequency that we were emitting. So maybe there is a constructive and destructive interference also in your room.
And Huda says the frequency increases when the distance decreases and vice versa.
Are you sure you're watching at the frequency plot? The first one is the intensity over time, and the second one is the frequency over time. Be sure to be looking at the correct one. The frequency versus time should be very constant. The second plot should be very constant. More or less, because there are some points in between that could escape, that could go everywhere, but more or less constant. And in the case of the intensity versus time, it should be varying over time. So, do you notice that? Do you know where your microphone is on your device? Can you locate the microphone on your device? So,
Yep.
if you are pointing the microphone directly to the computer, it will be receiving more or less a direct sound, right? But if you tilt the phone away from the computer, it could be measure a different thing. Even though I didn't move it away from the computer, it will change how the sound is received by the microphone.
Mr. Javier, Ana Maria is asking decreasing how? Can you repeat, please?
Decreasing in the sense that um, you can hear as you move away from a source, you can hear a less intense sound, right? A lower volume of the sound. If you're moving away from a loud room, you will see less and less and less sound until you more or less don't hear anything from that source. Yeah, right. So the theory says that it's following a very specific law, the attenuation law, and it's an inverse square law. Yes, you are correct. The problem with the theory is that in practice, the theory doesn't work most of the time because we are in the real world, and that's considering a perfectly spherical space where there's nothing around, and the sound doesn't bounce to come back to the microphone, and the sound doesn't mix with every other things, and we as a person are a material and can affect the experiment. Sound bounces off of us also. You can check this if you put a constant source as I did before, and you move around the room. You will see some variation on the intensity of the sound picked up by the sonometer, especially if you put the cell phone very close to your body, so you can move around and you will see how the intensity varies. So there is a very interesting idea because we can following the theory try to see if that idea of the inverse square law is correct in practice, and how we'll be doing that, how can improve the experiment to get more reliable results. That's the question. How can we move closer to what the theory says we should get, at least in the sense of the experiment that we are seeing right now. So what do you think? How can we improve the setup? We could move away to a different location, do it with a different source. For example, you have in your computer usually two speakers, not just one. So the sound that's coming from the computer can be two sources and not just one. So it wouldn't be a square law, it would be the mixture of two square laws. What do you think? How can we improve this experimental setup to get more reliable resources? So it doesn't depend on us. It doesn't depend on the room. Miss Thaler says I should have rotated the phone so the speaker would have been closer to the computer speaker. Yeah, that's a good idea. Be aware of where the microphone is very important for this experiment. And we usually don't think our cell phone as a microphone, usually as a camera. A good photographic camera, right? Okay, so this idea uh, can be shown to your students so they can figure out what's the best way to measure sound. And the good news is that you can try right away your idea of how to improve the results. You can try it. You can see if how it improves if you point the cell phone always in the same direction. If you don't move around the room, if the source is just one and not two. Move to an empty room, yeah, or an empty field like a playground or a park to see if the sound doesn't come back to you directly or doesn't bounce and moves to the microphone as a secondary or third source of sound. This is what inquiry is based on. This kind of question and this kind of discovery pursuit that we are following right now is what inquiry is all about. And we use this inquiry model to try to teach some science, and not all only the scientific concept, but also how science is done, how science is done by scientists and by people all around the world. And these kinds of questions also brings to the front challenge and brings to the front the real world kinds of problem that students have to understand in order to move around the world and do a lot of different kinds of jobs in the 21st century. So we are teaching them not only what to think, but also how to think. What's the proper way of facing a real life problem? And in Lab4U, we try to build around this idea of inquiry and do a more understandable structure of how to perform the inquiry, separating the different steps so you can see how students perform in each one of them and how you can address their difficulties and their personal skills. And this is mimic just uh, almost one-to-one with the 5E instruction model that's very present in the NGSS curricula. So we have almost the same steps. They are not in the same order and they don't have the same focus uh, because we focus on the experimental part. This 5E model is more general, but it's very, very interesting as a structure to classes. So the question would be, why inquiry and why now? And we have some ideas, but the proper ideas always come from the teachers. What do you think of this experience? What do you think of playing with your cell phone and trying to figure out some things directly from that? So if you have any idea of what you felt during this small experiment and what you think your students can improve uh, doing this kind of activities, please let us know in the chat.
Yeah, maybe we could even unmute some mics and ask our fellow teachers here. What do they think? Why inquiry? Why now? Why is it important? Who wants to share? Mrs. Martha says the students have fun when they speculate, guess, and then test to see what happens. Roshan says to intensify curiosity.
Ana Maria says, very interesting also for home labs at distance. And that's very important because we cannot forget that students are at home. They are doing or trying to learn from wherever they are. And if they have a cell phone around, they can do that. They can experiment by themselves. They don't need to be at the lab at the school.
Michael says increasing engagement among the students.
Yeah.
Interesting. Why do you think that, Michael? They do not burn out just from listening. Well,
Yeah.
indeed.
It's very boring, especially if you are not around them, and most of the time you cannot see their faces to how they react of the things that you're doing. So this puts the ball on their field, so they can do things and engage directly in the phenomena there that we try to teach them about, right?
Absolutely. And Mr. Javier, as we're coming to an end of this webinar, I would love to listen to other teachers. What do they think? And share with us, Mr. Javier, what are the next steps? What do we have to do now? Brodney says students become responsible for their learning. Yes, indeed. And Michael says also a more challenging hierarchy in learning to remember, from doing the skills process, no?
Yeah.
Remember more from doing.
Yeah.
Uh,
If a student can post a question and then answer his question, that's a far more significant than just trying to answer a teacher question by experimenting, and it's far more enjoyable than just answer a question theoretically as an idea. So in that sense, yeah, doing is always better than just saying things or just listening to things.
Mrs. Martha says, since my students are doing distance learning, some of my students can use younger siblings to get help assistance to make it more fun. Yes, indeed. Martha, do you want to share unmuting your mic?
We have also seen that. Yeah, we can there. We
Asked,
cannot hear you right now,
wait,
Martha.
let me ask to unmute. There you go.
There.
I just want to share that because my students got all the Lab4U labs crammed into their curriculum, I started by putting the first 3 as extra credit. And the honors physics, boy, they never can get it. They already have an A, but they want more points. It's very effective. And so I was really moved by their comments. And the second one, I was grading it, I sent it to Kamal because he said, at first I was confused and it was just plotting distance versus time, displacement versus time. And at the end, he said, oh, this is so much fun. I'm so excited to see what's to come. So now they're going to have their formal one with the forms, and it's exciting to see them actually doing physics at home, because otherwise I would just be a math teacher. Nothing against math. I love math. This is what makes the distinction between physics and math is them actually collecting data. So so far, anyway, the kids have been doing it are pretty impressed. So I'm excited to see now next week they're going to have to do 2 different labs. It's I forgot the 2. I can't see. Oh, here it is. Right here. The 2 labs that they have, I'll tell you, is graphs to help map and moonwalk. They have both those labs. And I know
wow.
it makes a difference before their test, because then the test is a week later. So it's pretty exciting that they actually, they don't have the Pasco equipment at home, but they have something better because now they're in more control of it.
Absolutely.
You
Absolutely.
are
Thank you so much for sharing
you
that.
did point out some an interesting idea in there in your comment, that you can involve the families. We don't usually think of the families as a learning opportunity, and that step of involving a parent, involving an aunt, a grandpa into the experimenting, or the siblings or the friends, it's a very rewarding experience because you are trying also not only to understand it for yourself, but also trying to explain it to others, what things you are trying to accomplish with
Javier,
experiment.
I'm actually requiring that their lab report have a photo. Somebody has to take a photo of them doing the lab. And I'm doing that because I learned last year, this encourages them to do the lab and not just borrow data results from somebody else.
So it's very, very interesting. This is an opportunity that maybe at other points of our life, it wouldn't be an opportunity. It just be a passing by thought.
Right,
And
right.
this challenge is also present. It will be present in the near future, and different schools have different models how they are facing this challenge of the virus. Maybe 100% distance learning to protect the students, maybe hybrid models when you see some classes are on person and some are not, and maybe there will be some privileged students that will have 100% on person classes, maybe some of the subjects, not all of them. So we are trying to figure out the best way to help each scenario. We know that experimenting is essential to an in-depth learning of the subjects and of the skills that they need. So if you have any of these situations or others that you are planting, don't forget that you have an opportunity in experimenting, in doing things hands-on, and teaching them how real science is done. And this process will teach them the 21st century skills that they need in every field that they will encounter in the future. And uh, an old profession or a new profession will be needing the same kinds of skills to solve new problems and to face the uncertainties that these kinds of situations put in our ways. So the best way to do that is to teach them how to think critically, to communicate results, to um, lean on to others, to be helped. So these are skills that students really, really need right now and will be needed in the future. So we can teach them that today with things that we have at the reach of our hands. So thank you very much to all. We
Thank
will
you.
be sharing a survey, so you can let
Thank
us
you.
know what other subjects you want us to talk about in the future. Um, we will be doing more experiments in the future. We will be presenting new things for Lab4Physics and for Lab4Chemistry in the near future. So be aware of your email, and that survey that Kamal put on the chat help us very much to improve this space. So if you wanna say anything, or if you want to comment on questions that you have about sound, about this space, please put your question in the chat so we can address it, or send it through the survey so we can later on review it and address it in a different webinar, in a different space. Very, very appreciated your time here with us.
Thank you so much. Thank you, everyone, for being with us today. Thank you, all the teachers that are making a difference in so many students' lives today. We know it's a pressing time, so thank you so much. Thank you, Martha. Thank you, Brodney. Thank you, Roshan, and all those who are chatting here. One of them said, I think if we could have webinars every week, we do try. We do try to have constant webinars. We have tutorial videos in our teacher portal. We've got a podcast. Uh, Javier, if you can put the next slide with our contact details, so that you can see our last one, contact details. We are inspired by the work that all of you are doing. So thank you so much for the great work you're doing with your students. We are here to help. We want to help you so that you can inspire your students with the beauty of experimentation, so that they can see the world around them and experiment. Thank you so much, everyone. We're gonna stop here the live webinar, and you guys can unmute yourself too if you want to stay longer and chat more. Thank you once again, and see you soon in the next webinar.